All right, so here you had a few basic questions. I gave you one function to work with the whole time. Okay, this kind of, the W shape, right? So you're looking at the same problem. All right, so the first thing I asked you was, what are the zeros of the function below? Okay, so remember, zeros are anywhere that we cross the x-axis. All right, it doesn't have to be like this where we actually physically cross it. Okay, it can be where we kind of just brush upon it. Okay, so here we do have two zeros, right? And they're going to be at -3, 0 and +3, 0. All right. We didn't go over this explicitly yesterday, but your zeros will always, the y value is going to be 0, right? That's what by definition a 0 means. Right? Be careful. This up here, the 0, 4 would be the y-intercept, okay, which, might help us to graph, but it doesn't tell us anything really. And then this, I just put that there. All right, so just be careful. All right, so the first one, we had two zeros at -3 and +3. Okay, next I asked, are there any relative minimums? Okay, and then if so, how many? So relative minimums, you're looking for dips, right? Like we saw, did I show you? Okay, so yeah, like here, right? There's our relative minimum. Okay, now I didn't ask you about maximums because we do have one definite maximum here at 4. Now, when we see closed dots at the end of a function like this, do we know what that means? What does it mean when we see a closed dot on a graph or a number line? Anybody? All right, that closed dot means that the function ends there, okay, but it is equal to that, right? That's what when we see on a number line, it's less than or equal to, right? So I have a point at what, -5, 3, and I have a point at 5, 3, and it ends there. I don't have anything at -6, -7 further to the left, or anything above 5 here. So if I was asking about relative maximums, okay, you would have 3. You would have 2 at the endpoints here, and then I don't know if I went over this yesterday, but this one here would be called the absolute maximum. Okay, so the absolute maximum is the highest point that you're going to get. All right, and when we start talking about vertex and things like that, we'll delve more into that. All right, now the last two, okay, that's where I saw some confusion, if there was some. On what intervals is the function increasing? Okay, so here we're looking for a positive slope. All right, so we read the graph from left to right. Okay, so starting here at -5, 3, okay, I have a negative slope, right? So that's not increasing, it's not increasing, it's not increasing. Now here at -3, it starts to change, right? We have that dip and it starts coming up. So our function starts increasing at -3, right? I'm going up, 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 up. And then up here at x equals 0, I start to change, okay, and we start going down. So my first interval for increasing would be from -3 to 0. Okay, so right now, this problem, yep, that looks like it's going to be it. From 0 to +3, I'm still decreasing. And then again, from 3 to 5, we turn up and we start increasing. All right, so we have two intervals that we're increasing, right? And this is how we would show it: -3, 0, and also 3, 5. Okay. Now, you could have done kind of a process of elimination, right? This function only goes up or down. There's no constant part, right? A constant function would be a straight horizontal line, right? So we don't see that. So if it's not increasing, okay, it's going to be decreasing. So I start to decrease, like I said before. As soon as the function begins, I decrease from x is -5 to x is -3. All right, so down here. And then I start decreasing again at 0, and I stop at 3. All right, so I do want to say one thing. Be careful. We're going to be switching in between coordinate points, right? So like -5, 3, and interval notation. When I talk about interval notation, these are only these are only x values. Okay, in interval notation, I don't care about the y value. If I'm asking you what is the point that is the 0, okay, this is an x and that's a y. That's an x and that's a y. All right, so there's going to be some back and forth. Now, if you see a square bracket, automatically that's an interval. Okay, so that's going to be like this, where we have an interval, that's increasing, or something like that. If you see a square bracket, that automatically tells you it's an interval. If you see this U, right, this inclusion, that means we're talking about intervals. You won't see this U if I'm talking about 2 points. Okay, here you notice I put and, right? So if it's 2 points, right, these are 2 separate coordinate points. -3, 0 is that dot there. +3, 0 is that dot there. Okay, any questions about the assignment? All right, so if you haven't done, I'm sorry?
These assignments count for a grade?
I mean, they'll for the ones that are labeled check your understanding, it's more of a completion thing. So just as long as you do it, you're good. The homeworks, they count as an actual grade. So, if you don't do too well,
Can you do more problems like the ones you did today? Because now I understand it and before I didn't.
Okay, yeah, we're going to go through some more things. And then what I'll do maybe tonight is I'll post an actual homework. And then, so today, as long as you did the assignment, you're okay. Like, if you got them all wrong, you're not going to get a 0. You're going to get a participation grade. When I do the homework, okay, then that'll be an actual grade.
Thank you.
And also, so I forgot that, I haven't had you guys as students before. I have a policy that if you don't like your grade, if it's below a 70, you can fix your work and I'll average the grades together. All right. So in this case, do it on a separate piece of paper and just email me and say, oh, hey, Mr. Murray, last night's homework, I didn't do too well. Here's the corrections. And then, when I punch the grades into Infinite Campus, I can bump it up a little bit. I won't be able to give you 100%, all right, but it'll definitely be better than whatever you had. Okay, is that cool, guys? Does that sound good?
Yeah.
Okay, and that goes with if we, I like how we're doing it now, but once we get back into school, that's how it works for tests and quizzes as well. All right, so if there's a quiz or a test that, you feel like you didn't do too well on, I let you guys do revisions, and then that'll help your score. Okay. Right. Any other questions about the homework? All right. I want to go over a couple problems with average rate of change, and then really I just have one more thing to talk about with this. All right. And we're still going to be looking at graphs and equations for a little bit. But the next topic we're going to actually incorporate a little geometry in it. We'll see when we get there. All right. So we're continuing from yesterday's notes. So we're still talking about average rate of change. So if you want to continue where you left off yesterday, okay, or if you want to start new notes, that's up to you. All right, but what we're going to do today is we're going to actually find the average rate of change. All right, so we'll start with an example. Let me see. Good. All right, so we're going to take a look at the function x cubed minus 3x. And we're going to find the average rate of change from 0 to 1. All right, so here we're using our equation, the formula that I gave you above. Now you can look at the graph, okay, but say for argument's sake, we don't have a graphing calculator right now. Okay, I'll show you how to do it with a graph after, but it is good to know how to do this algebraically. Okay, so right away, they give us 2 out of the 4 things we need, okay? We need f of x2, f of x1, an x2, and an x1. Well, I have the x1 and the x2 here, right? So that's straightforward. That goes in our denominator. So what we have to do now is we have to find our numerator part, okay? So we have to calculate what is f of x1, okay? So, right, we plug in, we substitute the x1 with what it's equal to, 0, right? And now I'm just substituting in the 0 into my equation, right? So we're going to have 0 to the third minus 3 times 0. Pretty straightforward. 0 minus 0 is 0. Okay, so our first coordinate point, if you want to write it as coordinates, is 0, 0, right? That's our x1. You could call this y1, but we're going to call it f of x1. All right, so that's the first part. All right, we're almost done. We got 3 of them now, f of x1, x1, and x2. So now we're going to find f of x2, right? x2 we said was 1. So I have 1 squared minus 3 times 1. That's 1 minus 3, and that gets us negative 2. So my second point is going to be 1, negative 2, right? And this is my x2, f of x2. So now we're just going to plug it in and simplify. Okay. Again, like when we talked about slope, for some reason, if you forget which one is which, right, which one should come first, as long as they match up in the denominator, you're good. Right. So if you accidentally did f of x1 minus f of x2, as long as this is a 1 and that's a 2, and you have those switched, oh, excuse me, you're good there. All right. So remember our y's go in the top. All right. So my f of x2. So we'll say average rate of change. Okay, so we're going to have negative 2 minus 0 over 1 minus 0. Well, this is pretty straightforward. Negative 2 over 1 is negative 2. All right, so let's take a quick look at the actual graph. X to the third minus 3x.
Wait, can I copy this down real quick?
Yeah, sure, go ahead. Let me know when you're good.
All right.
Okay. So here we have the graph of, it's kind of, see if I can make this smaller. Okay, x cubed minus 3x. Okay, so my point at 0, 0, right? That's what we found there. And then down here we have our other second point, 1, -2. So what we're doing is we're connecting those 2 points with a straight line. Okay, so there would be a dotted line there. Actually, okay, I'm not looking at the whole thing, but I'm looking at that to there, right? So this line that connects the points would have a slope of -2, okay? And that slope of -2 is our average rate of change. All right, so that's how we take a look at that. Now, we take this concept and we apply it to a lot of other things, okay? I can find, the average speed, right? If, for the first hour, you drive 50 miles an hour, and then this 3 hours later, you're driving 20 miles an hour, right? You can average those together to find the average speed. All right. So your question today will be based on this. All right. So you'll have an equation where you have to find the average rate of change. The last topic, though, I want to talk about. There's one more topic.
So you're always gonna give us the x1 and x2 values?
Yes. Yeah. You will have those. You find the y values and you plug them into this form.
Okay.
Okay. Okay. Now, this last part is more of a concept than a point of interest. Okay. So what we've seen so far are specific parts of the graph that either help us define the graph or, help us actually graph it out. Okay. So you have, your max, your mins, your zeros, and your average rate of change. All right. This is more of not a qualification. That's the word I'm looking for. Oh, I don't know. It's too early. It's more of just like a terminology. Okay. So I'll show you the mathematical way, and then I'll show you with graphs. Okay. We say a function. We say a function is even when the value of f of x is equal to the value of f of -x. Okay, so a very basic even function would be x squared. Okay, if I plugged in, what do I want to say? If I plugged in f of 2, right, 2 squared is 4. If I changed this sign to -2, I still get a positive 4. All right, so because those are equal, that function x squared is even. And then we can say a function is odd, okay, is if I plug in the opposite sign, I'm going to get the opposite answer. Okay, so what I mean by that, again, a very basic example of an odd function is x to the third. Okay, if I did f of 2, right, 2 to the third is going to give me 8. When I change this sign, f of -2, that's going to get me the opposite sign. My answer is negative because I changed the inside to negative. Okay. We don't see this too much more, okay, but it is good to know because I don't know if they're changing the final, but it was something like this was on the final, I believe. Okay. So with the last few minutes, let's take a look at the graphs, all right, and what I mean by that. So actually right here, x to the third minus 3x is an odd function, okay? If I plug in 1, I get -2. If I change that 1 to a -1, that changes my sign of the y to a +2, okay? Another way we can look at this, okay, at these two, is with symmetry. All right, let me type in another one to show you. So say we have I don't know, x squared plus 3. Okay, so x squared plus 3 is an even function because when I plug in 1, I get 4. When I plug in -1, I still get +4. Okay, even functions are symmetrical over the y-axis. All right, so actually let's write that down. Oh no, I just dropped something. Okay, even functions are symmetrical over the y-axis. In geometry, did you guys go over point symmetry? I know that was 2 years ago for some of you.
No.
Okay. So point symmetry is a little different. Okay, it's kind of like I'm trying to think of a good example. Let's see. Okay, so point symmetry is everything's reversed. Okay, so here, right, it's kind of like a mirror image on the opposite side. Okay, also known as point reflection. All right, so let's take a look. Okay, so something like this would be point symmetry because they're on opposite sides, right? So it kind of goes across diagonally to the quadrants. So if you had something up here, point symmetry would put it down in this quadrant. Okay, in reality, what we're doing is we're changing the sign of both the coordinates, right? So if here I had a point, I don't know, 4, 3, this would be -4, -3, right? And by definition, that's what an odd function is. Oops. Okay, so tonight you'll have some homework, 1 or 2 questions on average rate of change, all right? And then tomorrow we're going to move to translations. All right, so a little geometry, but slightly different. We're going to actually take a look at it with, equations and how we deal with it algebraically. All right, guys. One last quick question. Does anybody know if they'll be at back to school night tonight, or probably not?
Probably not.
Probably not. Yeah, that's usually how it goes. I won't take offense. Actually, it's probably better for me because I don't have to do anything if nobody shows up. All right, guys. Any other questions? I can't find the Google Meet. All right. If that's it, no questions, then I will let you guys go. All right. Enjoy the rest of your day.
Yeah, my bad.
And I'll see you tomorrow.
Bye.
Bye.
Bye-bye.
Bye.